There they are. Thank you. Oh, just run on the chat. I don't remember. Yeah, thank you.
It's okay now. Yes, I didn't want to have all these separate parts.
You're still going to drop it then? I need to test correction. Yeah, just be late.
Thank you so much.
Test correction if you want one time or do right now. There's a warm-up projected on the screen, so go ahead and get started on that.
You're fine up there.
Plug it in. Warm up is on the board, so please make sure you have gotten started on that. You just take a moment to check your partner's method for number one, make sure it's acceptable.
Yeah.
You can find the first one.
About 30 seconds. Okay, so. Good morning. Happy Monday, everybody. A couple of housekeeping things are kind of things we need to do before we get into the good stuff. Are we good with the date here? How do I want you to see this? How do I want you to see it? Okay, so PEMDAS, where would this fall in PEMDAS? P is actually a type of grouping. So first, you do everything on the radical first, 35 plus 169, the square root of 169. It's 13, yeah. So how else do I want you to see this? That's kind of best. Algebra 1 student. How else do I want you to see it? Ah, yeah, right triangle. Geometrically, this would be the legs, right? 5 and 12 of the right triangle. If that's the case, the hypotenuse would be 13. So normally I put a triangle up here, but I thought once in a while to put the expression that leads to that hypotenuse. But you can see that before it puts together. Yes. Yes, it is. Thank you for reminding us. Yeah, so that's another bookkeeping thing. Quiz is on Friday on days 1 through 4 of the unit. So today is day 3. It'll also be on next time. Yes.
Isn't it days 1 to 4?
Right.
On the like the last quiz, like on.
Oh, will it be on the hub? I don't know. Remains to be seen. I think this one will be on paper though. Yeah. Is it better on paper?
It's really hard to do it on.
It's annoying, right?
Yeah, so like
Okay.
separates like.
I love it because it's like grading so easy. Yeah. Yeah, but I'll probably do it on paper. We'll see. I don't know. Last thing you need to know about AP pre-calculus. Have you heard about it? New exam this year, AP pre-calculus. We do not offer that class, but you're in advanced pre-calculus, so you may be interested in taking the AP pre-calculus exam in May. So I looked at the topics and we'll be covering everything.
Oh, okay. This is to do.
But what if we do that?
No, next year's AP calculus,
Yeah.
AB. So 2 completely separate classes.
But we're allowed to like the AP.
So you're able to take the AP pre-calculus test this year, which will be on the things that we're doing in class. The only difference is most AP classes offer a review before the AP exam. None of that. We're not going to be doing that, so that would be on you to take to review. Oh no, it's only for your personal interest if you want to. Yeah, I have no desire for you to take it, but I'm interested. If you choose to take it, I want to know where you're thinking. Yeah.
One, this is like new, so like you have no idea from that one, like the question.
Right, this is the first year it's being offered. I haven't given practice or anything.
But also, I know in physics, even though we're technically taking AP like lab, there's like a whole major section that's left off in the course.
Mhm.
But you think every single unit, even.
Yeah, I was looking at the topics and at least 95% of what's going to be on the exam, we're going to be covering before the AP exam. It's kind of cool.
There's more out.
Yeah, because there's a month after AP exam. Yeah, okay.
When is the AP registration date? Tomorrow?
It is tomorrow,
So like tonight by like 12?
tomorrow night.
Oh.
So if you're interested, let me know and I'll send you the passcode or whatever code it is that register for it. I'm happy to share that with you, but I don't want to speak to everybody. I want you to take initiative to reach out to me and say, hey, I'm interested in signing up for this. And I'll send that code to you. Well, yeah. Next question. Any other questions? Yeah. What's like? That's a good question. It's similar for everybody. The most practical reason for taking AP exam is what? Credit. AP credit so that you
Don't have to take it in college.
don't have to take it in college. It counts for college credit. Depending on the college you go to, they don't all accept AP credit automatically. But if you get a 3, 4, or 5, I think many places will. But many private schools just don't accept any. They want to know that you know their version of the math. Won't accept like the calculus score. Yes.
But what if in college, don't you? Think how does that change?
I guess there are enough colleges that offer pre-calculus now where this makes sense. Maybe, but you're right. Normally freshman math is calculus. So yeah, how do they rectify that? I'm kind of interested for those of you who are interested in doing it to just see how this class, if it prepares you for an AP exam, especially if you're not going to
do anything extra on your own. It's like maybe we'll do the tests or something like that, but. If you're feeling the class, if you're enjoying it, if you're enjoying the kind of curriculum, we're gonna maintain that kind of pace all year. Think about it. But it has no effect on your grade in this class at all. And in fact, I think you get the results like in July. So I wouldn't know. Yes. I don't have one that. Here's a backup. I can even know I can hear you. Okay. Any other bookkeeping things? I don't think so. Okay. So common error for number one, and it's an understandable error because I haven't talked about it yet, is to start by switching x and y here and think that you did this one. Of course, that's not what I want you to do though. What that's doing is saying, here's a function, find its inverse. Although we have this, that is not proving or verifying that the function is inverse. I didn't tell you how to do it, but did you get it on the homework? Yeah. The method is to make it composite. So if you plug g of x into f of x, the result should be x. If you plug f of x into g of x, the result should be x. And you need to show me both to verify that the inverse is one. Yes, this like a point of methods that might that wouldn't be enough to prove that they're inverses. So yeah, mathematically, although I totally get what you're saying, mathematically we plug each function into the other one to make sure the output is an x. So, yeah, and that's just the standard with it. So that's what I don't know. Plug one into the other x. Are there cases where that the verse that I know of. But or maybe there's gotta be some other, right? Otherwise, why people every time two believe it. Yeah. And I just kind of want to talk about the visual implications of this. And I hope we're comfortable with all these machines I put up here. If we're doing out of composing g of x, what machine will that be? And G is first. Remember that f composed with G is the same thing as f of G of x. So G x first goes into G. So just as an illustration, x will go in here, then output is
G of x, yeah. Then plugging this in here, of course, the output would be f of g of x. And if these are inverses, we should be left with x. Right? If they truly undo one another, the input becomes the output and the output becomes the input, right? Like just in reverse. Like, you should get an x there. Same thing for the other one. In this case, we'll just plug into G first. So x goes in here, and I put an arrow there. So you get an f of x, which goes in here, which is G. So this is G of f of x. And if these two are truly inverse functions, this will result in x. I have left myself without a lot of space, and I feel like I don't want to do a whole lot of this, so I'm just going to do one of the cases. Should I plug G into F or F into G? Okay, F into G it is. First one I heard was F into G. I'm going to do this one first, but it's, I love them both. Okay, so if I'm playing F into G, it's going to become 3 times x over x plus 3 over 1 minus x over x plus 3. Does that make sense as a start?
Yeah.
Okay, what do I do next? Multiply top and bottom by x plus 3. Are we okay with simplifying? If it's complex fraction, let's uncomplexify it. Multiply top and bottom by x plus 3. And of course, here I'm going to have to distribute, so x plus 3. On the top, I'm left with 3x. Thank you, Jonah. On the bottom, I'm left with x plus 3 minus x, which very quickly becomes x, doesn't it?
Yeah.
And it should, the same thing should happen with the other way. So yes, we indeed we indeed did find out. I have no idea if those would make any sense. That g of f of x is equal to x. Yeah,
If you show that you're multiplying the property model by x plus 3 and with x, would you like 2 points off?
good question.
But like, if you do.
But you skip this one and just said it's equal to x. I may have you argue for points back after I take them off. Yeah. But just saying that it's equal to x doesn't show me that you know the. Doesn't have a big picture with that, really appreciate, that we know how to get x. But I wanna see everything. I'm not just gonna tell you the end of the story, I'm gonna tell you a story. If I tell you a story. I'm not that kind of teacher though. Unless it's a mathematical story. Mr. Reeves likes to tell stories, I think. And other teachers. Okay, number 2. Would you please show me what h of x looks like? Oh, okay. So, does it have an inverse? Why do we have to restrict the domain? It's not 1 to 1. Are we good with that? Yeah. You can check to see if a function is 1 to 1 by using the horizontal line test. We've already checked that it's a function with a vertical line test. Definitely a function, but it doesn't, as it is, it doesn't have an inverse unless you restrict the domain. Have you done this already? We got to this problem? Yeah, I'll give you a minute to work through it. And make sure you're finding the inverse of the one that is invertible.
Just another 25, 30 seconds, and we'll go over this. Okay. To restrict the domain, what should we do?
X is, are we good with that? X is greater than or equal to -2. We could say greater than or equal to like -1, but that we want to keep as many y values as possible. So let's do red here. So this is what we're going to focus on. Okay, so from here, what do I do? I find the inverse. So I'm going to start by saying x equals y plus 2 squared plus 1. Are we good with that?
Yeah.
Okay, from there, we know that,
You can do X minus 1, so
yeah, x minus 1, x minus 1. the square root, so y plus 2 is equal to, should I say plus or minus? All right, this is where we have to choose. I'm gonna choose positive because
That's not a function.
otherwise it's not a function, and doing the right side. Positive. If I took the other side. And choose the negative one. I'll do both of them just to make it clear what's happening here. So now I have y is equal to square root of x minus 1, minus 2, and I left the left side blank because I'm gonna just write. Nice, well, h in this case, but h inverse. Thank you for not saying -1. Seriously, thank you. I hope that you're all making that switch in your brains and in your mouth when you're doing these problems. Okay, so if I were to graph this, are we good with what it would look like? Yeah, symmetric to y equals x. So we have at 1 comma -2. I think we'll come down here like this and then go up. And last time in class, oh, yes, well,
What if you, what do you do, why was the eventually?
yeah, I want to talk about both of these. Thank you. I will take through the domain and range from here. Yeah, last time I think I forgot to put a cap on them. Like it doesn't go.
So let's talk about domain and range for this, make sure that it makes sense. For H and H inverse, the domain that we chose was, as Elika said, x is greater than or equal to -2, which means for the inverse, the range should be y is greater than or equal to -2. Does that match what we've done so far?
Yeah.
It's kind of perfect, isn't it? And for the range of our function, for h, the range of a function was y is greater than or equal to 1, which means for our inverse, the domain should be x is greater than or equal to 1, and that also matches, doesn't it?
Wait,
Oh.
no.
Domains are x. We switched to x and y.
Oh,
We did this, we switched the relationship. So yeah, x here, x here, and y here. That whole issue could be, eliminated if we use interval notation. All we're gonna have to write it back. Is there a question? Okay.
Wait, why do we choose one side?
Oh, for this?
Yeah.
Well, anytime you want to, see if a function is invertible, we have to make sure it's what kind of a function?
1 to 1.
1 to 1. It wasn't, so we had to restrict the domain.
Oh.
We had to. Otherwise, there is no inverse for a.
Right.
It's
So
not
if it's not 1 to 1, then we have to come up with an interval that we match that.
Would you say that one more time?
If it's not 1 to 1, we would have to come up with an interval that we would have to set.
Those are beautiful.
Oh, wow. I know. Awesome.
Yeah, we have to come up with a level and then continue from there.
Wait, why shouldn't you do so h of x less than -2, and then for inverse, you can take -3 at times.
Good question. We could, let's do it. So. Because we're all individuals, we may choose different things, and that's okay. So let's say we chose this side, and I'll call that the purple side. Is that purple? Does that look kind of purplish? Okay, so I'm gonna do this again. The only difference is gonna be starting here, y plus 2 is going to equal, in this case, we choose the negative x minus 1, which means our inverse is this negative. Can you imagine what this graph looks like? Right.
And hopefully it makes sense that if I were
To graph this, wouldn't it just do this? And so we have a parabola opening to the side. You can see that the reds are reflections of one another, and the are reflections of one another. And if you're to play with the domain, it should all work out perfectly. Just be mindful of this. We think it's like all real numbers and, or you say all real numbers here and then if they're restricted here, it needs to match. Right, they need to match. They'll always match if they're true inverses of one another. We take a minute just to check with your partner about all this stuff and make sure that all the questions are answered. Okay, so on the scale from this to this. You get it? Well, make sure you get it because of course sometimes it could be on the quiz on Friday, so I don't want you to miss out on these points. Okay, let's get to the packet. Finally. Trigonometry. I told you this was the second of how many trig units? Three trig units, and we haven't done a single trigonometric ratio this whole time. And so you get extra credit for that. What's that? Oh, you're like chomping at the bit for logarithms. Huh? Logs are great, but not yet. Oops. We're block 6. Page 9, excuse me, page 9. Okay, let's start with a graph of y equals sine of x. Now, before I even do this, I want to check your understanding of something. Before we graph it, every function has inputs and outputs. Trigonometric functions in particular have a special kind of input and output. Could you please discuss with your partner what are the inputs for this function and what are the outputs? I never don't have anything. I just okay. And don't tell me all of them. You know that's the input.
You know, it's right here, going positive, negative. Up until this year, I've only dealt with 0.93. You know, it's in terms of trigonometry, the sign goes down. Yeah, now it's not even 360. They don't want the negative angle. I don't think you get it. So this is you never imagine why. Happening definitely the sign of that. Well, let's think the number, you know, what I mean? Oh, one more time. It's a rate ratio of 2 sides of the triangle. Opposite compared to the hypotenuse. So of course it becomes negative in the positive. It becomes negative when we get the right second quad and the third quad and fourth quad. Reminder, input for the base function is angle output is the ratio. There is no input ratio. Angle to radians or degrees, that it matters what mode your brain is, and you've also noticed matters what happened. Okay. How many of you have been burned by that? I was in the wrong mode. Yeah,
I don't know. Yeah.
it's not the first time. Like, if you don't know how to change the picture to go to the mode button on the calculator, it'll give you a whole list of the, there's the great reading. Find the appropriate thing to highlight. Okay, so let's graph 2 periods of sine of
X, one on the left, one on the right. Let's graph 2 periods of sine of X. One period over here, one period over there. So you're graphing 2 periods of sine of X. One on the left, one on the right. Must I? You better. Or else you won't.
forever. Good job. I did a pretty good job. I think I should label my y-axis. Yeah, did you label yours? Let's see there.
Oh, okay. Is sine 1 to 1? Obviously not. It's very definitely not 1 to 1. But we do want to make a sine inverse function. So what we're going to do, what I'm going to ask you to do, now look it up, and ask you to restrict the domain so that it is 1 to 1. I'm going to tell you the rules of restricted domain for a convention function. We want values that are close to 0. The x values are close to 0. And if you're choosing between positive and negative, always choose positive. So first, for the business is choose values close to 0. After that, if you're choosing between positive and negative values of x, choose a positive one. You want to discuss what you're going to do with your neighbor?
Sam's like, no, I can't.
Okay. So I'd like to share with us your thoughts on weather restriction. Ben?
Just make it 101, looking the number negative pi to pi.
Do you agree with that?
Yeah.
Could you repeat that? I keep
If you want to make it, or do you want to make it 101, that what the certain negative pi to pi.
So like here?
To on the apps. Yeah.
Does that make sense? Very nice. Someone in my last class chose this interval. From here to here, which is a great interval. This is a great interval. That's not supposed to be zero. So we want to make them standard that we ought to come up with a feeling and to solve it. So this is what we're going to do. Thank you for your help, Ben. Realize that we're going to say?
Yeah.
Slow your thunder, maybe next time. So we're going to find the inverse of that. Do you have any idea what the inverse function of sine of x is? It is sine inverse of x. Yes. Nice. So y equals sine inverse of x. Would you please graph this function? Not on the same axis. Would you please graph sine inverse? And by definition, inverse, so it's right. No, on a different axis. It gets too complicated otherwise. Can you show me what you marked on the x-axis, please? Show me what you marked on the x-axis, show me. X-axis. It should be like -1 and 1, does that make sense? Because it came from the y-axis to the other one. First, the lower y value is going to be -pi/2. And the upper one is going to be pi/2. Let's get some points. I see. How many points should we use to graph this one? Just 3. The first one comes from pi/2, comma 1. So it's going to be 1, comma pi/2, 0, 0, and down here. Does that make sense with 3 points? Now, getting the curvature is a little difficult. There are 2 different ways it could go, but there's only one of which is correct. I want you to imagine a sine wave going up the y-axis. That's what a x equals kind of y is. Sine wave going up the y-axis. But it's not really a 90-degree rotation. It's a rotation over the line y, or reflection. So it's going to start like this. Does that make sense? Like if I were to continue up, I'd be getting to pi over here. But I'm not going. I can't do that. And then continuing down. This is a graph of sine inverse.
We're also.
I'd say it's opposite of helping because it's incorrect. It goes the wrong way, doesn't it?
Oh, man.
It goes the wrong way. So remember, you're going to we're going to talk about the domain and range, but what's the domain and range? Yeah. Okay, so domain. Enzo, what'd you get for the domain? For this graph? -1 to 1, is that inclusive or inclusive? So the closed interval -1 to 1. Do we agree with Enzo? Enzo, do you want to tell us the range too, or do you want to? Wait, it's universe has got to decide. Oh, you could guess. Next. -pi/2. The other side. -pi/2. Is this a closed or open interval? It's closed, isn't it? We have points right there. Are we good with this? Domain and range? Ladies and gentlemen, you have a new parent function. Right, this could be shifted to the left or right, up, down, could be stretched in all directions. Yes, Sam. Oh, good question. Have asked. Yeah, it's like science. No, that's it. Yeah, it's not, we're not gonna have anything for you to become great. It's just a single piece. It's just a single piece that's been reflecting on the mind. So let's think about the output. The output, we're going from -pi/2 pi over two. You can discuss with your partners, which quadrants does that correspond to on the unit circle? Again, negative five or two, let's quadrants is that correspond Okay, please show me the quadrants. Show me like 1 and 2, 2 and 3, 5 and 6.
I think eight.
Oh, 7. Okay, so I'm saying 1 and 4, are we good with that? From the unit circle, it's saying negative 5 or 2 is over here, so it's literally goes from negative 5 or 2 to 5 or 2. Right, so this quadrant is like 1 and 4, the right side. Even though the data is expressed in quadrants 1 and 3, information comes from the angles that we know about. Okay. So. Here we go. You ready to have some fun? And more fun, I should say?
Yeah.
As you should. What is this right with that? No. This question is asking which inverse, which angle has the sine that's equal to 1/2? Let's do this. Let me write this here. So this is like thought bubble. Which angle has a sine that equals 1/2? I think you already know the answer. Check with your neighbor. Do they know the answer to it? So what is it? 30 degrees to agree, 30 degrees? Or another way to say 30 degrees toward the 5 or 6. How are we supposed to know this? I hope you know the unit circle. I hope you know that at that 30 degrees or that 5 or 6, you got to know this is both of these. You know that the coordinates are, what is it, root 3 over 2 comma 1/2? All right, so we know that the sine of that is 1. How about 5 over 6? Yeah, we don't pay attention to any other answer. We just want the ones between negative 5 over 2 and pi over 2. That's it. If you give me other answers, it's going to be wrong, and I'm going to be testing. So even though I know you're trying to be really good, I think you're trying to be really complete. If you have a for inverse trig, there's only one answer. One answer. So you try to do 5.
Yeah, right now you're just doing top left. Calling a couple people.
Give a few more seconds. 10 seconds. Okay, ready or not?
Here I come.
Silence, please. Maggie, could you tell us what you got for sine inverse of 1? Are we good with that? 90?
Yeah.
Is that the only correct answer?
Yeah.
There's no other version of that we can do? Or pi over 2. Either one is fine. Depends what mode your brain is in. I couldn't care less, unless it's saying to answer in radians. Now let's just check that with the graph. We just graphed sine inverse of x. Do you see what sine inverse of 1 is?
See it on the graph, right? One.
Is pi over 2. Which you know is 90 degrees. So it's just putting all the information, getting it in the right place. And sine inverse of root 3 over 2. Natalie, what'd you get? What's that? So 3 pi over 4. Okay, are we okay with this? No, what's wrong with this?
I got
That's the wrong one.
The wrong quadrant. It's got to be in the first or fourth.
Oh, it has to be.
It has to be. So I think you have the right y value. Oh no, this is a root 3 over 2. I'm not. Yeah, root 3 over 2. Let's see. Pi over 3, is that right?
Yeah.
And let me check this pi over 3 that's right here. That's 1/2 comma root 3 over 2. Is that what we're looking for?
Yeah.
Yeah, so this is pi over 3. That's the only other acceptable answer would be
Pi over 3 is
60 degrees. Patrick, did you have a question? Oh, we're gonna do that next. After this 3-minute stretch break, so we'll continue talking at 12:36. Everyone's checking their Facebook, I know. So much action on that Facebook. I have Instagram. You can try. I don't accept followers until after graduation. But thanks. Yeah. Yes, you have to find me. Okay, oh, almost time, almost time. Okay, hope you had a good stretch break. But please discuss with your partner, what's the sine inverse of -1/2?
Sine inverse.
Ben, it sounds like you got it.
I got it. You're thinking about the straight one.
Okay.
So.
I give you
My other side, most people said 11,000, because a great answer, but unfortunately, it's not the right one. It's not correct. So what am I looking for? It's not some kind of thing.
I mean, I guess, I don't think that's the right answer. It's not that it's-
So you know that it's wrong, but you're not exactly sure how to explain the right answer.
I think, well, if you were to look at like, if it's looking at the. I realize if you're looking at sine inverse of 1/2, then that's like -1.
Mhm.
It's just, I guess, like you just add it up to and then opposite on quadrants, but if I had.
I'm not sure what your answer is.
I don't know.
Okay,
But.
okay. Scott, I'm sorry, Ryan, do you have an idea? -5 or 6, what do you think?
Yeah.
Does that make sense? -5 or 6?
Angle has to be -5/2. 5 is just got to be in That's so smart. The domain is exploding. Like, no. To get to that high, I think you have to go way past the second and the third. And then it's just worth farther. It's the right angle. It's the right angle. The wrong angle.
So this is -5 or 6. Do you think that might be a common error on the quiz for the next step? Extremely, because we're so used to it being 11/5 or 6.
Negative, or negative 6. Next, do I call a couple of lucky winners?
Actually, try all of these on the right.
Yeah. Don't worry about the lower left. That's out there. Yeah.
Like you want a sign and then there's it goes on.
Yeah, you can do that. You can do that. Yeah, all of them. You can do- I believe in you. I believe in you.
So much I don't like the. I don't get This is the part where you get up to.
Oh, yeah.
Oh, you could just add.
Are we ready? Sine inverse of -1. Okay, if you're not done, okay, I'll finish in a minute. Sam, can you tell us what the sine inverse of -1 is? Do we agree, -pi/2? Either that or -90 degrees, depending on what mode you're in, or what mood you're in, really, too. Do you see it on the graph that he's correct? You see it on the graph of sine inverse? So very clearly, sine inverse of -1 is -pi/2. If you're in radians. Thank you, Sam. Sine inverse of -√3/2. Elika,
-5.
do we agree? -5/3? Yes?
Yeah.
Okay. Thank you. Very nicely done. Of course, degrees would be appropriate too if we say -60 degrees, right? -60 would be fine as well. This next one, Lauren, did you get anywhere with this? Well, let's do it together. What do we do first here? Okay, I think that's the place to start. Is this true? -√2/2? Seems good to me. So sine inverse of -√2/2. Okay, so Lauren. Now what? We do. Can you help us out with this? Look what she's doing. She's like, yeah, the unit circle right in front of her. She got her pencil out. I love it. You're doing great, Lauren.
Get your pocket.
I'm celebrating.
Yeah. Yeah, Lauren, do that right.
Under pressure. If you don't know the country, I want to hear it. Day 5 and 4, we think of that?
Yeah.
You're right there. You're on the precipice. Good question. Is it okay to say or 315 degrees?
No. Because that's not in the.
Not in the domain.
That was why.
Instead of degrees, it would have to be -45 degrees is great. So maybe I need to adjust something up here to make this perfectly clear. Or so we could change that, or 90 degrees. The highest we can go is 90 degrees. On the bottom, yeah, it just depends what you're doing here. The lowest you go is -90 degrees. Can't go outside that window. Okay. I have one more to do. I'm gonna do this problem. I need silence. We're running low on time. And do this 2 different ways. I think you're gonna like one of them, and you might like the other one more. This starts with sine inverse of -2/3. There's something a little bit uncomfortable, guys. Something a little bit uncomfortable with this, and that -2/3. It's not a standard place on the unit circle, right? The other ones were pretty comfortable because it's pi/6, pi/4, we know that. But -2/3, do you even know where that would be? We're gonna have to draw it out, but which quadrant should we be in? Are we sure it's 4th quadrant? Yeah, we're dealing with inverse sine, which is either in the 1st quadrant or 4th quadrant. This is definitely in the 4th quadrant. I'm going to just draw a corner, well, a 4th of the unit circle. And if this is -1 right here, I think -2/3 would be right about there. You see the angle
Yeah.
that we're looking at? Right about here, does that make sense? Counting, this is.
Like this is -1, and 2/3 1. But I'm looking for the angle without y coordinate. Remember the y coordinate is the sine that. You're talking about the angle with sine value is -2. Good question. Thank you for that answer. If you're talking about the angle, anytime you say angle, is not whose sine is -2, that's why I highlighted that y value.
So this isn't asking for that angle, it's asking for the,
It's asking for the cosine of that angle, isn't it? For the cosine of this angle, which angle? The angle whose sine is -2. So there's the angle. How do you get this cosine?
maybe a little Pythagorean theorem. You see the triangle we're dealing with here? We need coordinates. There it is. We know the y coordinate is -2/3. I think we can get the x coordinate. I'll give you a little time to do that work.
But isn't way too negative to be like x?
No, but it's,
Oh, sorry, yeah, sine, what's sine?
but we want the x value. We want the x. Okay, so what's the the x value?
Yeah.
Wait, we know that this is -2/3. We know the hypotenuse is 1, so we're just doing x squared plus -2/3 squared is equal to 1. So x is equal to square root of 5/3. Is this right? I'll leave that work to you. So square root of 5/3. We just found out that the cosine of that angle is √5/3. That's one way to do it. That's one way to do it. And quite honestly, it's not my favorite. I really like the unit circle for the standard places. Right, when there's a 1/2 or √2/2 or √2/2.
That's a good one.
I love it. But -2/3, that was a pain, wasn't it? So instead of doing unit circle, what's another option? Just deal with that. A triangle. Where should a triangle be?
Whatever you want.
It has to be specifically in the. So. I'm gonna do this again, but in this time, instead of drawing a little piece of the unit circle, I'm just gonna go ahead and draw that angle, theta. I'm gonna make a triangle there. Do I know anything about this triangle?
Yeah. It's like,
Right. Here we know that the sine of that angle, that's the right side. The sine of this angle is -2/3. So how do I calculate the rate? I remember what sine means. Opposite over hypothesis. So hypothesis is never negative, that's why the opposite is going to be
-2. And the hypotenuse is 3, right? The sine of theta is equal to -2/3. We're looking for the cosine of that angle, so we have to find the other side. Are we gonna do that? Pythagorean theorem, but without the fraction. Which gives us, what for this side? √5. Okay, so the cosine of this angle? √5/3. Because adjacent over hypotenuse. Yeah. Okay. Any questions? Do you need a minute to discuss this?
Oh, you prefer unit circle or triangle for this? By 5.
No. But if you prefer unit circle, you can force it. No judgment. But I question your Your judgment skills. This one, we're gonna do the same thing for cosine. Would you please restrict cosine, given the parameters I gave you earlier? Such that it is 1 to 1. Like, see what they ever did, how they restrict the domain to make sure it's 1 to 1. There are lots of different options, but only one that we're gonna go with. Would like to give us a suggestion? Yes, Enzo? Do we agree with Enzo, 0 to pi? Inclusive, that's exactly what we're doing, right? Their value is close to 0, we're choosing positive. And technically, if we could stay here, and it's still 1 to 1. We're trying to keep it close to 0. We can choose here, but there is positive, that's negative, it's positive. So let's graph it. Could you go ahead and graph cosine inverse? If I must, life is so hard. Maybe start with 3 points. For 3 points. Will, can you tell us what points, oh, can you tell us what you did with the x-axis? Like, what did you mark?
Yeah, I'm gonna say,
Do we agree with that? And how about the y-axis? What did you mark there?
I marked 5 or 2. And. Or 5 or 2. Yeah.
Like this? Are we good with that? Does that make sense to mark those? Okay, can you help us with the graph, or do you want me to call someone else? Okay, I like that.
So. You're gonna put a point at 0 pi over 0.
Okay,
Point at 1 0. And then you also need to point at -1.
and how did you know these three?
I just put this.
Nice, right, so like when originally had 0, 1, then you went 0, 0. Okay, so we do it, can look like everybody? So starting from that, 1, 0 is gonna do, you show me? Is it a diagonal line? It's gonna look like a cosine wave that's going up, up. Make sense? Well, thank you for your help. Really nice. Talk about the domain, range, and quadrants again. Domain, range, and quadrants. First domain is -1 to 1 inclusive, or the closed interval -1 to 1, and range starts with 0 and goes up to pi. Can you please show me the quadrants that we're dealing with here? Show me the quadrants. 1 and 2, because that's what we see quadrants. It's here to here, is that right? Oh, it's because we're going from 0 to 0 to pi. Literally. The first 2 quadrants. Okay, we have some time. Let's see what we can do down here. I bet you could finish most of it. We are running low on time. I want the first three answers. From Julian, can you help us out with the first three? Do we agree with Julian? Nice. So he's in degree mode, but you could also do it in radian. I'm going to trust you to be able to know those. I just want one of these at a time. Cosine inverse of -1/2. Henry, did you get that? Let's do it quickly. Unit circle. Oops. We're looking for where the cosine is equal to -1/2. Are we in the first quadrant or second quadrant? Maybe second quadrant. There's my -1/2. Okay, so what's the what is the angle? 110? No, 210? 120, are we good with that? Either 120, or we could say 2π/3. Thank you, Henry. Let's see. Avery, cosine inverse of -1. What's that, Avery? Are we good with that? 180? Nice. 180 degrees. Does that match what we have up here? Cosine inverse of -1 equals 180? Or pi radians. Nice, thank you very much. Cosine inverse of -√3/2. Ryan? 5/6, yes? Okay, unfortunately, we are running short on time. Before we leave, what I'd like to do is to take a moment to discuss with your neighbor. What are the main things to take away from this lesson today? Don't back up just yet. Don't back up just yet. Fine. Okay, so now it's quick, but what's something? What's one thing to take away? Okay, we wrote the -60. What else? Nice, back to y point. So that deals with specifically the switch to x and y. Okay, good. Nice. Anything else? Sine inverse, what's the number? So I'd be thinking which can sine inverse. First and fourth. Be careful about that fourth quadrant, right? Back up into it, don't go all the way around into it. And then for cosine, I want you to think first and second. So before you go, one word of warning, the homework you're gonna have to do on Friday, because I see kind of inverse and some other things on there. So it doesn't, if nothing is covered, skip it for now. And then we'll talk about it next time. Have a great day, folks. Thank you. My pleasure. My pleasure.